Hello, my name is Aida Manzano Carman, and I'm a fourth-year design engineering student of Imperial College London. This is the demo for my Sensing and Internet of Things coursework. For my project, I wanted to find out if there was a correlation between my sleep, my step count, and my mood throughout the week. In order to do so, I had to collect data of all three of these attributes. I wore a Fitbit for a week, and then I used the third-party Fitbit API to access the data on my Fitbit account and return a JSON object. I will demonstrate this now. Great. I have been authorized access to my Fitbit API using my client ID and my client secret. A JSON object was returned, and with the parser that I wrote, I scanned the information and created a CSV data frame. This is an example of my sleep throughout a night with the different phases and the minutes spent in that sleep phase. We can also see my step count and the different number of steps I took within each minute of the day. Once this was achieved, the next step was to be able to collect data of my mood in order to label the sleep and the step count data. This was in order to make predictions of whether or not there was a correlation between them. I acquired photos of myself throughout the week, and then I trained an image recognition algorithm in order to be able to return the mood predictions of each image. I selected the YOLO image recognition algorithm, which stands for You Only Look Once. This means it does not perform multiple scans of the image and therefore is much faster and suitable for real-time detection. I trained both YOLO v3 and YOLO v4. YOLO v4 performed better, but only YOLO v3 was compatible with the installation of Darknet that I had compiled. I will demonstrate how YOLO v3 performs in real time. This is a brief example. As you can see, the average frames per second in the prediction is almost 10. Once this was done, I used these weights to create a parser to scan through all the images that I had taken and return the predictions of my mood throughout the week. I integrated all of this data into one main data frame. I then visualized this for the client to be able to interact with using a Flask client-server system. This is what it looks like. The user can interact with the different variables of the dataset. They can toggle the details to look at the statistical properties of each, and look at the frequency distribution of each of the values of the dataset of that week. For example, we can look at also the predictions, and we can infer that I spent 40% of the previous week in a happy state. We can also look at the confidence of each of these predictions and see that it has a positive skew, meaning it tends to perform better than it tends to perform worse, i.e. my predictions are generally towards the higher end. We can also look at the interactions between each of the variables to find if there is indeed any correlation. We can also use this matrix to be able to visualize the correlation between each of the attributes. I also wanted to allow the user to be able to take a photo of themselves and receive a real-time prediction. To do this, I also used Flask, and I will demonstrate how it works. I initiate the server that contains the trained weights, and then the client is able to take in a photo of themselves, decide which one they want. I'm happy with this one. And then the server that contains the trained weights returns the prediction. It's decided that it believes that I am happy with a almost 72% confidence. This is what the client visualizes, and they receive the prediction returned with the confidence. Overall, this is my coursework, and I hope you enjoyed it, and thank you very much for listening.